Hi, my name is Andy. Welcome to this ARRI Tech Talk on virtual production or mixed reality production systems with a focus on metadata. Thanks for joining us. If you have any questions during this Tech Talk, please post them in the chat section. All right, virtual production. Let's jump to the first slide I've prepared so we can capture those who haven't heard about this system before. Virtual production means that you're no longer shooting outside in an environment, but you are actually shooting in an LED volume, for example. Meaning the camera is centered in the stage, you have your actors in front of the camera, but the background is rendered in real time to match with the foreground perfectly, in the best scenario. Now, lots of virtual productions have been supported by ARRI. We have learned quite a bit, and we've stumbled across a bunch of things that we would like to solve, or at least make easier to use. Now, one of these points is, of course, color rendition between the foreground and the background. The second is synchronization, and the third is metadata transport from our cameras. Today, we'll be focusing on the third point, metadata transport. To transport metadata from the camera means that you need it available in the Unreal Engine, so the rendering device in the background for the LED wall in real time. To do this, we have come up with a pretty neat solution. All right, let's jump to it. We are using the UMC, so the Universal Motor Controller, to stream metadata from our cameras, in this case the Alexa Mini LF, straight to an Ethernet switch, and the Ethernet switch will then provide the metadata to the Unreal Engine render nodes. The Unreal Engine render nodes therefore provide the image to the background in real time, mimicking what the camera is doing, and especially what the lens is doing, for the background to be rendered correctly. So with the current setup that we're going to present today, we have an Alexa Mini LF, the UMC4, we have some C-Force motors, we have a beautiful signature prime zoom lens, and we have in this image a WCU4, but we were able to go to the testing department upstairs and get a brand new Hi5 unit. So that's exciting. All right, let's continue. Sorry, that was me. Let's switch to the UMC4 so I can explain what exactly it does, especially in this scenario. So, as you can see, the UMC4 is connected to the Alexa Mini LF via the Ext port of the camera. And the Ext port of the camera streams all the relevant metadata that we want to stream into the network to the UMC via this port. We've also connected the timecode to camera and UMC, so they share the exact same timecode. And the motor controllers are not connected to the UMC in this case, but straight to the camera mount, meaning the UMC will only be used as a passive metadata listening and streaming device. Let's see what we have changed in the UMC to make this work. So basically, it's the same device as it was before. It works in the exact same way. We've only added a couple of features, meaning we needed to add certain functionality and therefore settings in the UMC to make all of this possible. So let's jump into the settings and I'll show you what we've done for this to work. Okay, so the first thing we need to set up is make sure that the UMC receives its data via the cam port. So it doesn't create its own metadata, but it just receives it from the camera. To do so, we need to navigate in the lens menu, and from there, the lens data source should be in the bottom exactly. The lens data source is set to cam, meaning that the UMC will receive its data through the export from the camera, and therefore there's no need to upload anything to the UMC. You just connect it and it works. So let's jump to network settings. These are also, well, they're not all new because you used to be able to update the UMC via the network, but we had to add a couple of things. So we'll navigate to System, Network, And as you can see here, there's a bunch of new stuff. The configuration source is the same as it was before in mixed reality productions. So in these big LED volumes, usually you have very precise control over what your network is configured for. So we've set it to manual because that's what most people would do. In the configuration part beneath that, the set parameters, you can set all of your IP addresses, you can set your subnet masks, just as you do with any other device. Beneath that, we can see the streaming mode. Now, this is set to multicast. We can change this to a unicast mode, but usually you want to stream the metadata to not just one device, which would be the unicast mode, but you want to stream it to multiple devices, so multiple render nodes in Unreal, which is why we set it to a multicast address. Now, I think beneath, no, we can show the parameters that we've set up now, just so you can see how it's configured. And those parameters will show up in Unreal as soon as we drop into there. So we've got the IP address set up, 192.168.0234, standard subnet mask, IP gateways are set up, and of course the MAC address, which is unique for every UMC4 device, or any device. All right, so let's go back to the home menu so you can take a look at the lens metadata. To do so, you just go into Lens and Show Parameters. And there you can see that the metadata from the LDS lens, the signature prime in this case, is streamed directly to the UMC. Now I'm going to take my awesome high five and start changing stuff. And as you can see, it works perfectly. All the metadata is immediately streamed to the UMC4, focus, iris, and zoom. All right, so one last setting that I almost skipped, but which is quite important, is you need to make sure that the streaming mode in the UMC is on. To do so, you just navigate into Menu, Metadata, and you can see Stream is on, meaning the Ethernet port that's connected to your network will continuously stream the data from the UMC4 to your designated devices. All right, so let's jump into the more nerdy part of this presentation, which would be jumping into Unreal, looking at the network data that's coming through on our Ethernet port, and making sure that's applied correctly to our virtual camera. And I'll open Wireshark. As you can see here, all of these running numbers, that's all the data packets we are receiving from the UMC4. So you can see here that's the designated multicast address, 239.192.1.1. The protocol is UDP, pretty standard, and everything's being received by my computer here. Now let's get into setting up the Unreal plugin and how to even configure your camera depending on your needs. So we've put up a home page in the Learn and Help section called ARRI Live Link Metadata. To navigate to it, Learn and Help, Camera Workflow, Tools and Apps, ARRI Live Link Metadata. And you simply scroll down and you'll find the Downloads page. And all you need to do is download this zip archive and you'll be ready to go, basically. That's all you need from our part, software-wise. Now, excuse me, I've already done that. I've got it unzipped here on the desktop. That's exactly what you'll be getting. First off, I want to drop into the documentation. So the documentation will give you a good idea how to set your camera configuration up with the UMC4 and designated motors, lens types, what cabling will you need, what camera is supported in what way, since of course every setup is always quite unique. And yeah, you can simply drop into the documentation and you'll know everything you need to know. All right. We also, of course, have integrated what you need to do to update the UMC firmware and how to set up the UMC as we just did in the beginning of this tech talk. Okay, so next is this plugin folder. The plugin folder incorporates all the source code for Unreal Engine. Now, this is in here because many studios are working with different Unreal Engine versions, some of which haven't even been released to the public, so they're just built for one production. So you've got the source code and you'll be able to build from source this plugin if you like or if you need to. The third one here is the pre-built version. So these Unreal Engine versions, we have simply pre-compiled our plugin so you can use it in those designated versions. We've had studios still running on 4.2.6.0 and of course studios running on the greatly improved 4.2.7 version of Unreal Engine. Lastly, there's a subfolder called the UMC4 firmware. Now, there's a reason we don't release this firmware as an official release for the UMC4, and that is because it is beta software. You need to know that we wouldn't want every first AC out there owning a UMC4 to immediately update to all of these new features, simply because we have to test everything, now every real-world scenario, before we can say, okay, this is an official release. But for virtual production, all of the use cases you find in the manual have definitely been tested. There's no need to worry about damaging your product. All of that is, of course, secure. All right, so let's jump into Unreal Engine and check out how to set all of this up. Okay, I've, of course, created a project beforehand. It's pretty standard. It's just based of what Unreal offers you in the beginning. I'm running 4.2.7 and I'm just going to jump into how to set up LiveLink. In this case, LiveLink is the tool that captures the metadata, so the UDP stream that we saw earlier on in Wireshark. Okay, so to do this, the first thing I need to do is add a LiveLink source. Before I go into it, let's check out the plugins that are actually installed to the Unreal Engine. Because, of course, you need to take your ARRI Metadata plugin from the downloaded pre-built version, for example 4.2.7, and copy that either into your engine or into your plugin. This will be pretty standard for anyone using Unreal Engine, but anyway, I'm going to show it. It's in here. I've got a stage in 4.2.7. ARRI Tech Talk is the name of the project. ARRI Metadata is already in there. Okay, this in Unreal Engine results in the plugin actually being loaded and hopefully enabled, which in my case it is. And to make it work with LiveLink, I also have to check whether the LiveLink plugins are enabled. In this case, yes, LiveLink is enabled. And for 4.2.7, you also need to enable the LiveLink camera, which is new. It's still marked as beta, but it works just fantastically. So let's get going with the actual setup of LiveLink. So all you need to do is open the LiveLink window, which you will find here, Window, LiveLink, add the source, and input the values that we just saw in the UMC. Now, the IP address does not mean the IP address of the UMC. This is your IP address of your machine. So in my case, that's 192.168.0.10, hopefully. Yeah, okay. So as you can see, the subject is automatically created as soon as you receive data from the UMC4. Now, I've already changed the logs. Usually you'll see something like this, so basically nothing happening. But in the output log of the engine, you can make sure to see what's actually arriving from our plugin or from our UMC4 by changing the log category to verbose. All of this, again, is documented in the documentation. Let's hope I do it correctly. There we go. So now I've got a continuous stream and the representation in the output log of what we're receiving from the camera. In this case, the camera model, for example, is the UMC4, because that's where we're streaming the metadata from. I'll explain more towards that later on. We have the camera serial number, and we have the UMC serial number. So stuff like that is important for us to make sure that you are using the right software in your environment. And of course, we have aperture, we have focus distance, we have zoom, time code, tilt and roll from the built-in gyroscope in the UMC4. And we're also offering the raw encoder values, but let's get into that a little later. Let me change the log back to its standard so we don't flood the log and get a slow computer. Okay, let's start with timecode, because timecode is quite important for us to stream metadata into Unreal Engine. So I'm going to drop into the content browser over here. I've already created a media profile which you'll need to stream the timecode via live link to your project, or it's a way of streaming it. And in this timecode provider, I have to override the settings, which is here. I need to choose a live link timecode provider. And then I need to choose my subject, which is the UMC4. I'll apply and I'll save. And now you can see down here that the timecode is streamed to the engine. Now this is important because of course you want all of your metadata that's coming into the engine time-stamped with the timecode. This is not only important for the on-set workflow, but of course also if you're recording other metadata in Unreal Engine, you would want everything stamped to the same timecode and therefore synchronizable in post-production. Okay, now next step for a standard live link workflow would be to look at the Cine camera, which is already created in this project, and to that Cine camera you add a live link component, which is already highlighted for me. Usually you type in live link component, you say I want that controller, give it a name, awesome name, and again choose the ARRI UMC4 metadata stream. And now I can again switch back to my awesome high 5 unit. I'm really happy we got this because, yeah, it was really last second that we were able to get one. Okay, now in Unreal Engine, I'm going to select the Cine camera so you see that something is actually happening. We've got here, I'm highlighting it. I'm not sure whether you can see it, but this is the current focus distance and the current aperture. So when I change the aperture, it updates live in Unreal. Might be a little difficult to see, but the really good thing to see is, of course, the zoom. Now this is all real time, so we don't have anything that's blocking or delaying the stream from the UMC4. It just goes straight into the Unreal Engine with the timecode. So we've got almost no delay on that metadata. All right. Okay, so that's live link. Now, there are a couple of studios out there who might want to do some more sophisticated workflows in Unreal Engine, so they want more control over what metadata is coming in, how and when, and what am I going to do with all of that metadata. Because what we've seen now is, okay, the live link plugin emulates the camera, it translates the values from the real camera to the virtual camera, but what if I want to do something with all of that metadata before applying it to the camera? So, let's jump into blueprints because we're also offering a live link less workflow. So what I'm going to do is I'm going to delete the live link from here and from there and start fresh. So I'll jump into blueprints, just the level blueprint to be fast. First thing you need to do is add a variable. Now we're going to call this variable ARRI device because we've created an own object type, which the object name is ARRI device. So all I need to do is type ARRI. I'll find ARRI device and create an object reference to that. Now, with this ARRI device, this needs to be initialized at some point when the play begins. The game begins, the play begins. So what I need to do is I drop it in, I call set ARRI device, and then I go into our custom function library, which is also found beneath ARRI, and I initialize the device. Now this is basically the same thing you do in live link, only that you have complete control over what you're doing and when. Okay, so let me scroll in a little. We've got the multicast mode. We have to set up our IP address again, 192.168. 010. And we've got the multicast streaming address, that's all default, as well as the part. And finally, I'll connect the return value to the ARRI device, meaning that this device, this object reference is now correctly initialized when I begin my game, so when I hit play. Next thing I want to do is stream the metadata, right? So again, I'm dropping in the ARRI device, getting it, creating another function which is also beneath the ARRI folder called get metadata. Now I want to get that metadata on event tick because I want it for every frame in the Unreal Engine, and that's basically it. That's all you need to do. This return value represents a structure of metadata, and the structure we can break, and that gives you a pretty good overview of what we're streaming from our camera through the UMC into Unreal Engine. Now, one last step before I forget it, because you shouldn't forget it, it's important, is you need to close the device when the game ends. So again, I'm going to get my device, drag out, close it, and on event end play, the device or the object will now be destroyed. Okay, compile, save, and that's it. Okay, back to the metadata. So one of the most important parts I feel is the camera state. The camera state lets you make sure that when on set a recording starts, you can follow that in the Unreal Engine without having to tell anyone that the recording is starting, which can be pretty tedious. So we've created an enumeration, so basically also a data struct representation of the camera state, which I'm going to drag out here. And in the Unreal Utilities, I'm just going to look at all of these possible states the camera can be in. So usually, hopefully, you're seeing camera system ready. What you want to catch is camera system recording. You might also want to catch warnings and errors depending on what you're doing in Unreal Engine. And let's try to do this live. So I'm just going to grab the camera state again and use these utilities, enum to string, to print out what state the camera is in real time. So I print the string. I hook that up and execute it with every frame. Let's hope I did everything right. I'll compile and save. And now, when I go back to my cool high-five unit and I hit play, then you can see this blue output, which is just telling me the camera system is ready. So I'm going to hit record for just for the purpose of presentation. And this has changed to camera system recording. So that means you can just automate whatever you want to do when recording starts in Unreal Engine. I think this is pretty cool and very, very helpful. Now, one last thing I want to show is that the UMC doesn't only do camera state or lens metadata, it also does pretty cool stuff such as the exposure index. We can stream the media capacity, so you can throw errors to or warnings to the crew through Unreal Engine when the media capacity runs low. We've got the clip number, we've got color temperature and tint values, and finally, of course, tilt and roll, as I mentioned before, from the UMC4. Yeah, so that's basically what we have done to hopefully make your life a lot easier in the virtual production environment, which is just, there's so many bolts and screws and knobs you have to turn to get everything working. Hopefully this helps you to get shooting faster. All right, so if there are any questions, I'm happy to answer whatever you have to throw at me.
Thank you, Andy, for this presentation. A few questions already came in. For example, do we have implemented Imperial values as well?
Yes, of course. I skipped over that. So if your lens is Imperial or your shooting environment depends on Imperial values, the UMC will stream Imperial values to the Unreal Engine, but they'll be correctly translated. So you don't need to make sure that you do the translation into the metric system of Unreal Engine. That's done for you by the plugin.
Thank you. And another question, is this software working with MacBook on Pro Big Sur?
No, right now the OS X version is not implemented or not compiled yet. If we get feature requests for it, we should be able to add it and make sure the plugin works for OS X 2. Usually, or for now, we've encountered that most LED volumes or mixed reality production studios work with Windows machines, so it's compiled right now for Windows 64-bit systems. But if you want it, just tell us and we'll make sure you get it.
And another question, is it possible to use the UMC setup with other cameras not made by ARRI?
No. No, I'm kidding, of course. Yes. Even though we don't want you, of course, to use other cameras, the UMC4, so it's universal and it will work on any camera system. You will not have access to the extended metadata, though. So you won't be able to get the CCT values, the tint values, the tilt and roll. What you will get is standard lens values, so focus, iris, zoom, and the camera tally. So is the camera recording or is it not recording? That'll still work.
And you presented everything over LDS. Does it work with ultra primes as well, for example, that don't support it?
Yeah, sure. So if you don't have an LDS lens attached to your camera, you will just need to upload the LDA tables that you created before to your camera, and then the metadata will be streamed to the UMC in the exact same way. So it doesn't matter whether you use LDA, LDM lenses, all of this will still work, and the metadata streaming will also work.
How can I make this work if I have two cameras rolling?
Oh, that's no problem at all. So of course you need two UMC systems, and you would want to stream to different multicast addresses, or you can also stream to this, well, you can't stream to the same multicast address, but you can stream to the same unicast address. And everything that will happen is that you get two live link subjects in your Unreal Engine. So multi-camera works too, no problem.
Okay, I think this is it. Thank you very much, Andreas.
Cool. Thanks for joining. Hope you enjoyed it. If there are any questions, feel free to contact us on not just metadata, but generally your virtual production environment questions, which can be long, as we have noticed so far. I had fun presenting this. Thanks for joining. Bye-bye.